In question 1 of this exercise, we have to prove that root 5 is irrational. So to do this, we will use the method of proof by contradiction. This is explained quite nicely in the relevant part of the NCERT textbook, and I've also covered it extensively in the QMath Leap course. So if you have any doubts, do refer to the relevant materials in these. So let's start by supposing that root 5 is a rational number. So we suppose that root 5 is rational, and let's say that root 5 when written in rational form can be written as r by s, where both r and s are integers. Now if r and s have any common factors, let's cancel them out to get this as a by b in the lowest form. So we have root 5. So we have root 5 as the rational number a by b in the lowest form, where a and b have no common factors. Okay, now if we square both sides of this relation, we get 5 equal to a square by b square. So I have squared this relation and I get 5 is equal to a square by b square, which I can write as a square equal to 5b square. Now in this relation a square equal to 5b square, the RHS, the right hand side, is a multiple of 5 because we have this factor of 5 here, and this means that a square is also a multiple of 5, and because a square is a multiple of 5, this means that a itself must be a multiple of 5 as well. And the result I'm using here is theorem 1.3 from the NCERT textbook, which says that if p is a prime number which divides a square, then p must divide a as well. So in this case, because 5 divides a square, then 5 must divide a as well. So in other words, a is a multiple of 5. So the first conclusion we get is that a is a multiple of 5. Now because a is a multiple of 5, let's assume a as 5 times m, where m is some integer. Now if I substitute this value of a into this equation that I have here, so let's call this equation 1, a square equal to 5b square. So if I substitute a equal to 5m into equation 1, I will get 5m square whole square equal to 5b square, and let me square this, so I get 25m square equal to 5b square, and let's cancel out a factor of 5 on both sides, and then I can write this as b square equal to 5m square. Now this relation again means that b square is a multiple of 5, because on the RHS on the right hand side we have this factor of 5. So b square is a multiple of 5, and again using theorem 1.3 we can conclude that b itself must also be a multiple of 5. And now because b is a multiple of 5, I can write b as 5 times some integer n. So what I have concluded is that a is of the form 5m, a is a multiple of 5, and b is of the form 5n, so b is also a multiple of 5. But these two relations put together, this is a contradiction, because in this form a equal to 5m and b equal to 5n, both a and b have a common factor of 5, and when we started out our analysis we assumed that a and b have no common factor. So we started out by assuming that a and b have no common factor, but our analysis led us to the conclusion that a and b have a common factor of 5. So this is a contradiction, and this contradiction is happening because of our incorrect assumption of taking root 5 as a rational number a by b. So this original assumption is incorrect. Hence, we can conclude that root 5 cannot be written as a rational number. So this original assumption that we took, this is incorrect. Root 5 cannot be written as a rational number. That proves that root 5 is irrational. And with that, question 1 is done. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.